everyone. Can you please tone down the microphone a little bit? I have quite a loud voice and I don't want to deafen you guys. So that'll be great. Oh, actually, he cannot really understand what I'm saying, right? So I guess I'm just wasting a little bit of my time. So hello everyone, or should I say, здорово, ребята. Мне очень приятно быть здесь с вами сегодня. Спасибо большое. Я чуть-чуть говорю по-русски и хочу сказать, что да, это очень приятно здесь быть. Я из Колумбии, чуть-чуть about me. С Колумбии, меня зовут Карлос, León или товарищ Леонов Карлос Лысович. Просто Карлос, просто товарищ Карлос. Я из Колумбии, но живу в Амстердаме. Да, я из Колумбии. Нет, я не барыга. Да, у меня дредлокс и живу в Амстердаме, но нет, я траву не курю. Просто не курю. Понимаете, пожалуйста. So that's a little bit about me. So for those of you who do not speak Russian like me, I am from Colombia. I'm 27 years old. My name is Carlos León, and I work as a software engineer at Container Solutions. And what I do, together with Container Solutions, is to help our customers try to smooth the process between migrating from old architectures, old infrastructure, old processes, into a more cloud-native way of working. And we're going to go into what that really means in a bit, but just bear with me for a second. That's a little bit about me, so let's just go. Story time. I would like to ask from the crowd, because I see there is quite the mixed crowd. I would like to ask how many of you, raise your hand, are 23 years old? 23? We have one. 22? Do we have 22? 22 года? No? So 23 is the youngest? Wow. Can you please raise your hand again? The ones that are 23? Come on. I'm looking at you. I saw you raising your hand. Don't be shy. What is your name? Как тебя зовут? Pavel. Очень приятно, Pavel. So what I'm going to do now is I'm going to show Pavel a picture on the screen, but I want the rest of you to not say anything. Don't give him the answer. Pavel, I'm going to show you a picture on the screen, and I want you to tell me what it is. If you don't know what it is, it's totally fine. Don't worry. Actually, you're meant to not know what it is. So, but anybody, please don't tell him the answer. Please, okay, just for a second. All right, so Pavel, what do you see on the screen? Pavel, do you recognize what is in there? Perfect card, punch card. Very good. Well done, Pavel. Yeah. So what I was hoping is that Pavel was like about 18 and that he didn't know what this was, because kids nowadays, they will not know what the hell that is, right? We've come a long way, and I was going to explain how punch cards worked, but it seems like pretty much all of you know what it is. I had to investigate it because, to be honest, I had never seen one. I had heard about it. I had heard about, the old developers saying, yeah, back in the day, punch cards, that was the real thing. That was delivering software, you really understood and talked to the machine. I'm like, okay, Grandpa, okay, thank you very much. Not that you guys said that you don't look that old, but you get what I mean. Okay, so punch cards were for a long time in the industry, and that was the way that we used to deliver software. Somebody had to sit there, punch the cards, and I don't need to tell you guys this story, but you get the idea. Somebody was punching these cards with some machines, and then somebody had to ship them, and the way to verify that the program was actually working was insane. I cannot even imagine myself doing that nowadays for a living, but people did that for decades. Actually, the first punch cards that came to existence were back in 1750, where some dude for the textile industry decided to use them to introduce some sort of punch cards, and centuries after they picked up back in the 30s, 40s, I don't know, whatever, I don't even, this is too old this is way before my time. I was born in the 90s. I'm more of a Ninja Turtles kind of guy, not punch cards. So soon enough, the floppy drive came in, and this revolutionized the way that we deliver software. Because you see, to read punch cards, you needed a really big machine that could read the punch cards. And these big machines were not only difficult to transport and to ship around, but also they were super expensive. And so as we started to reduce the space and the size of computers, it was way easier then to deliver software. And so we introduced the floppy drive, or the magnetic media to transport software. And this revolutionized the industry. So then something like the Commodore 64 came to the market, and then people could actually I'm probably wrong about the Commodore, because probably there was something before that. I just don't know, I'm too young for this. Okay, so can anybody tell me what was before the Commodore? Anybody?
The Sinclair ZX81.
The what?
Sinclair ZX81. Spectrum. Both.
The Spectrum is older.
No, ZX81.
Oh, it's the same. Okay, so anything before the Spectrum that was more or less the same thing?
The Apple one.
The Apple one. Anything before that one?
Altair.
The what?
Altair.
Altair? Was that Russian? No? Okay, it sounds kind of Russian to me, but okay. Anything before that? Well, okay, so we've come quite a long way, right? Quite a long way to probably my phone here, which is $100, is way more powerful than the Altair, right? So we've come quite a long way. Anywho, these revolutionized the way that we deliver software, right? However, does anybody know what this is? The Zap 64? This was a magazine that was used to talk about software for the Commodore 64 and similar architectures. So basically, they would talk, okay, there's this program, just like a computer magazine. But what was really special about it, and what I find fascinating, that I can only imagine, is that the way that they delivered software in games back in the day were through magazines. So you bought the magazine, and there was the code for the game. So you bought your game, and then you had to punch in the code to have the game in your computer. Can you imagine? I mean, when I came to computers, it was already Windows 98. And to think that you had to punch your code into the computer to have the games, I mean, how many of you guys did that, actually did that? Can you raise your hands? Okay, keep your hands high, keep your hands up. How old are you? 28? How old are you? Why are you 28 you did that? That doesn't make any sense. You were born in 1989. Jesus. Okay, I'm just going to skip this part. I don't want to go there. I don't want to go there. We're getting old, guys. We're getting old. You're 28, and you think that you're young. I'm 27, and I think that I'm young. But look at this. Just I saw this the last couple of months ago on Twitter, and look at this. In the I'm getting old department, a kid saw this and said, "Oh, you 3D printed a save icon." Pardon my French, but fucking kids. God damn it. So the reason why I hate the kid for this is not because he's being innocent. It's because he's making me feel old. And I am not old. I'm 27. He's not old. But these guys don't know what this kid is. Hell, kids born today, they will not know what is a life without internet. Think about that. Think about it. I don't know if you have already had the opportunity to see kids at the, what do you call that? In YouTube, the channel where they show the kids all technology, and then it's like kids react to Game Boy, and they're trying to touch the Game Boy screen. I mean, like, Jesus, these kids are nowadays, they don't know what it was to punch your game into the Commodore 64. I mean, we've come a long way. Anywho, moving on. The hard drive existed before the floppy drive, but they were massive. But we've been trying to reduce the size of storage. That nowadays, today, somebody gave me a USB stick to put my slides on. It's this big, and it's 64 gigabytes. And this guy, look at it. How much is it? Probably it's like 1 gigabyte. Back in the day, wow! What are you gonna do with 1 gigabyte? You will never fill that up. Never. And now it's like 1 gigabyte. It's like, okay, I'm running out of space for my pictures. Does anybody know what is this? What is that? A hard megabyte? 100 megabyte floppy drive, a zip drive, okay, 100. So I was hoping that somebody would give me that answer because I couldn't find on the internet how much this capacity of this guy was. It's so, okay, I never saw this in real life. Okay, and then we went to these babies. Remember, 700 megabytes, oh yeah. I don't know if you guys ever did it, that these guys would get full of fungus and then you would lose all the information. So a trick was to use a marker and then you mark it with dark black marker so that it would resist the fungus for longer, but it didn't work really. It was just wishful thinking. So it was 700 megabytes, and then the DVD came with 4.7 gigabytes, and then the Blu-ray was, I don't know, something 8 gigabytes or I don't know, whatever. It was a lot of space, just bear with me. So the media that we have been using to deliver software has been changing all the way from this, right? To this, and this. And finally to this. This is a GIF, but the GIFs don't work on PDF, I realize. But if you've seen the GIF on internet, you know what this dog is doing to that poor USB stick. This was what we were using to deliver software, and at some point, when the internet came up, then we started delivering software using Web 1.0, or as we call it now, because back then it was not called Web 1.0, it was just called the internet, the highway of information, or whatever that they call it. People were having access to internet, so they had access to email, they had access to some sort of software, search engines and whatnot, but they were limited by the fact that there was not a lot of information on internet back in the day. There was some information in Hasta La Vista, in Alta Vista, Google was starting, Yahoo. I don't know what was the version before Yandex in Russia. Anybody? What was before Yandex? Crumbler? Rambler, okay. There was Rambler. Like we've gone quite a long way from there, right? I can only imagine, unless Yandex is just a rip-off of Rambler. I don't know. I have no idea. But right, there was not a lot of information, and also the internet sucked real bad. Remember when we had the dial-up, right? And we were downloading the Matrix GIF was like 1.3 megabytes, and then you were downloading, you were like 70% downloading the whole day, and all of a sudden your mom picked up the phone to call someone, and you're like, no, hang up, I'm on internet. And then you would lose the whole day from downloading your GIF. It was super lame, it sucked. And then Web 2.0 came in, but the reason why it was a success, it was because people now had access to high-speed, reliable internet connection. We went from the 56 kbps to 1 to 10, 100 megabits per second internet connections. And so this revolutionized the way that we deliver software, because not people anymore had to download software or wait for the Encyclopedia Encarta 98 or the Windows 98 or Vista or XP, whatever, right? That you had to go to the shop, bring money, buy the software, get the CD, DVD, go home, install it. It would take a whole day. We even made a business out of it. When I was a kid, I made a couple $20 or $30 for installing Windows on people's machines. I'm pretty sure that you guys did it as well. That was a whole business, and it was not a lot of money if you did it on the side, but if you did it full time, it was decent money. So we made business out of installing software that was shipped around. It was a mess. From an industry point of view, it was an upgrade from punch cards, but it still sucked. How many of you guys got to install Windows 3.1 from floppy drives? There we go. Wow, holy crap. Okay, you guys are old. How many diskettes was that? 20. 20? No way. Okay, so for those of you who don't know how it worked, you were going to install Windows 3.1 on your computer, you insert the floppy, take it out, put the next one. Okay, wait, hold on. Wait for the whole installation of the whole 1.44 megabytes to be done. Take it out, install the next one, and repeat 20 times. It was absolutely insane. So we've gone quite a long way. So you can imagine how having software without having to install it revolutionized the whole thing. Because, you see, people hate to install software. And what is more, people are lazy. Whenever you had a software and said, hey, Windows security update, would you like to install this? People are like, nah, I'm okay. I'm just going to skip this one. Nah, I'm okay. Hey, we have the latest version of Microsoft Office and it's for free. Would you like to download it? Like, okay, maybe not. You know, it was not like a really smooth process. And if you had a really bad security issue in your software, waiting for the customer to install the security patch was impossible because people don't want to do that. People are lazy. People just want things to happen without them making an effort for it. We're all like that. It's very comfortable. It's very easy. I don't want to make an effort for my program. Just make your software work. Just ship it without bugs. That would be great. So why Web 2.0 was a great success? We could deliver software without people having to install it. But what is more, we could deliver updates on the fly, live, right there, right then, without people having to install anything, without having to beg the user, can you please install the patch for my software? Just push your code, hope for the user to refresh the page, which would happen often, and then a new version of your software was delivered. That's as easy as that. And this also revolutionized the industry from a business point of view because software as a service was introduced. And so then we didn't have any more licensing like, okay, for 10 spots you pay 100 million euros or whatever a year. Instead, the business model switched to a subscription-based model. So now you didn't have to pay year by year, but month by month. And nowadays we even have minute by minute. It is that cheap. It is getting really cheap. So it's making it easier for the companies to deliver software, but it's also making it easier for consumers to buy software. All right, and then the iPod happened with the touch screen and the Wi-Fi. It was super clever. People thought, wow, that's a really super expensive MP3 player. But only after the couple of versions when it really kicked in, they say, hey, we actually can convert this guy into a phone, and everybody can have this smartphone on their pockets. And it happened, and it was amazing. Everybody loved it. And everybody wanted one. They couldn't afford it though, because it was super expensive. I remember in Colombia, it was about, the first smartphone that came out, the touchscreen, was about like $1,000. Man, that's like 3 years worth of saving. I was never gonna buy one of those, but now they're $100. I have one. I have one of the $100. I had a $500 smartphone, and it was a piece of crap. It broke all the time. The quality of the pictures were not great, so whatever. And now I have downgraded, but the fact is that I can have my email, I can have my applications, I can get in touch with my colleagues, with my family on the other side of the world. I can make sure that my code is working, you know, take a look at the pipelines, I can talk to my customers, and I can do everything, almost everything, from my phone, from my pocket. So the industry has come a long way when it comes to delivering software. However, we're seeing in the last couple of years a shift. I guess it goes in waves, because in the past we used to deliver diskettes, right, or CDs, and the client, the user's computer was very heavy in terms that it was being attacked with a big piece of software, and you needed a lot of memory, you needed a lot of CPU, etc. And then people say, oh, hold on, now we have client-server architecture, so we can put all the load on the server side. So then we came with the concept of thin client. So the clients were thinner in resources, and all the processing, all the hard work was being done by the server. And that was the trend for most than a decade. And it was then shifting back to heavy clients or thick clients, because now your phone can do a lot, and computers can also do a lot. And what companies are trying to do is to push applications towards your phone. You can use Facebook on your browser, but it's best if you use the application. And if you look at the application, it's like 90 megabytes. The same goes for Yandex, for Uber, the Twitter, whatever that is. The companies want to have an application installed on your phone for a different reason, not because they want to avoid the server side of things, but more for marketing and business purposes. However, let's not drift from that. So the internet usage has been increasing throughout the years. So I want to take a look at the growth from the last couple of decades. So in 1995, we start with 16 million, around rough, this is rough numbers, right? So in December 1995, there was an estimated number of users of 16 million using internet. December 2000, 361 million people December 2005, 5 years after, 1,018 million people. December 2010, roughly 2,000 million people using internet. That's a lot of people. December 2015, 3,366 million people use internet. And as of June 2017, there is a rough estimate of 3,885 million people using internet. If you ask me, that's a lot of people. A lot of people. Imagine all these people trying to hit your application. I mean, we're having customers that they have 1,000 users, concurrent users, and their application is totally dying. We are not so ready for this growth. We were not expecting it. Because, to be honest, yeah, they say, oh yeah, how long is it going to take for people to buy computers? Everyone will have a computer, but like in a couple of decades. And then the smartphones came, and everybody now has a computer in their pockets. Okay, it's not a full-blown computer, and nevertheless, you're hitting a service. Your phone is talking to WhatsApp, or to contacted. It's talking to Google. It's hitting services all over the place, right? And now imagine your phone, and all of our phones, and all the cities' phones. Moscow, St. Petersburg, Vladivostok, I don't know, Berlin, Amsterdam, London, millions of people. Mexico City, 14 million people. Bogota City, 15 million people. All of them at the same time using web services. We were not ready for this. We were not. We were not. And it's going to get worse. Because now with the Internet of Things, it's going to triplicate 4 times, 5 times. We don't know yet, but it's going to be real bad. So we need to take a look at how we are preparing for this. Because if we are not preparing from a technical point of view, from a process point of view, from a business point of view, we are doomed to fail. We are doomed to fail. So what I want to ask you guys is to, by the end of the talk, ask yourselves, is my company ready for the future? Is my company ready for, let's not say 3,000, let's take a small percentage of this cipher. Let's go for 100 million people. Is my application ready tomorrow for 100 million recurrent users per day? Is it? Maybe it is already, but not everyone. I mean, if you're Yandex, probably you are ready. If you're Google, probably you're ready. If you're Facebook, you probably are ready. But is your company Yandex? Is your company Google? Is your company Facebook? Twitter? Is it? Oh, it isn't? All right. So then you need to re-ask yourself, how are we going to do this? So don't worry. By the end of the talk, I'm going to give you guys the hints and the keys to success. All right? So let's take a look at the process of how we've been delivering software throughout the years, how it has evolved, and how we're preparing as an industry for the future, for all these massive come of users that is going to happen. So if we take a look at the software delivery process, how many of you guys are not software developers? Can you please raise your hands? All right, that's a small number. That makes about 5% of the room. Okay, so we're going to go through this real quick, but it's going to be easy to understand. If you want to deliver software, actually, if you're writing software, it's because you want to fix a problem. This is what we do. As a software developer, what you do all day long is to fix problems. Normally, by making more problems, right? You write bugs. We write bugs. So, in order to solve a problem in a professional way, you need to make a process that is repetitive and that is trustworthy, right? Reliable. So we came up with something called waterfall. So we started with the wrong foot as an industry, and it's only taken us about 20 to 30 years to fix it. God, we're so trapped. Please help, help. So you start with defining the requirements, making a clear specification and definition of what the problem really is and how you're planning to solve it. So we said as an industry, okay, we're engineers and we're going to make this right. So we're going to start with defining the problems, then we're going to define the solutions, and then we're going to write the general overview of the solution. So we had the architect, right? Software architect. How many of you guys are software architects today? Hold on. 1, 2, 3, 4, 5, 6, 7, 8 people out of 300. 8 people out of 300. It's a very small role. It's not a small role, sorry. It's a role that is shrinking in numbers because the industry is changing. However, when we are defining our software and the solution for the problem, we had a software architect that was going to define all the classes and all the minor details, right, on how things were going to be put together. And then the implementation phase came in. when the developers will take over the architectural draft and start building the software. And this process, between 3 to 6 months, this one estimated 6 months, actual delivery 18 months, because we as software developers, we suck estimating, who doesn't? Then the release cycle would take another 3 to 6 months, and then we would deliver the value. So you can see that the risk was quite high, and only until the very last minute it was decreased, because it took a really, really long time to deliver that value. So imagine this, a friend of yours comes to you and says, hey, I have this great business idea. Let's say that Yandex doesn't exist yet, and we came up with the idea. We're gonna be rich, that's awesome. But you say to your friend, hey, I'm gonna build this software. It's gonna revolutionize the way that people search on the internet, because right now there's no way to find stuff. So I'm going to build this search engine. I'm gonna call it Yandex. But I need some money, right? Because you cannot just live from air. So you need some money to eat and to pay rent and certain bills and utilities, buy a computer, hire a couple of guys to help you code the application. And you tell a friend, I'm gonna need €1 million. But you won't be able to see the applications until 18 months. What do you think that your friend is going to say? If he's a really good friend, he will say, fuck you. If somebody that doesn't know you is like, okay, sorry, this is not going to happen. So we understood as an industry that this process was broken. It only took us 20 years to figure that out. Too long, just too long. So what we came up with was Agile. And we said, okay, how about we take this whole process of defining, building, and releasing, and we make it shorter. We're going to take let's say that this whole process took 12 months. In the end, with Agile, it is also going to take you 12 months, but instead of waiting 12 months to release, you release as soon as the value is ready. So if you want to build 10 features, you don't deliver the 10 features by the end of the year. You release feature number 1 as soon as it's ready. How many of you guys would say that you have an agile way of working within your companies? Good, that's about 50% of the room. How many of you guys are still doing waterfall? Okay, by the end of the talk, come backstage, hugs, free hugs for you guys. So we defined, thank you. We defined that the agile process was way better because we were releasing the value way more often. However, nowadays, the market is moving even faster, way faster, in a pace that we hadn't anticipated before. So now agile doesn't work anymore. Having 2-3 week release cycles doesn't work for the current environment, for the current pace of the market. It just doesn't work, unfortunately, and it sucks. Because we were comfortable with waterfall, and then we say, yeah, actually waterfall doesn't work. And when we had to migrate to agile, it sucked because it changed the way that we did things. And whenever there is change is not really nice to feel unless you really want it. But even when you really want it, change is really difficult. It's really hard. It changes everything that you're used to. And the problem with human nature is that we get comfortable too soon. And as soon as we're comfortable, we don't want to get out of there. Hey, I'm comfortable. Don't change the way that I do things. Don't change my language. Don't change my culture. Don't change the programming language that we're using. Don't upgrade the Java version. What are you trying to do? No. Let's not change from MySQL to Postgres. Are you crazy? Why should we include MongoDB, Ryak? Why should we do IoT? Why should we move to the cloud? Let's not do any of this. Change is really difficult, and you will see this in the companies as you go. If you're a consultant, you will see this. If you're working in just one company, it will be more difficult for you to see it. But the more you go to different companies, you will see that every time that you try to change something, there is a jerk reaction. And people are like, no, we don't want this. We want it, but not really. So what is the alternative now? Well, there is the microservices way of doing things, which is, you can think of it as Agile version 2. So you still have the 12 months or whatever amount of time that you decide for your application. And in the beginning, you define the architecture, but instead of waiting 2 weeks to define a release cycle and to release something, you do micro POCs, proof of concepts, all the time. And as soon as the proof of concept is ready, you ship it. It doesn't matter. It is going to be unstable in the beginning, but if you focus first on testing the idea, then you're going to be able to value the idea sooner. The sooner you bring the idea to the market, the sooner you will validate if your idea is actually gonna work or not? So to give you an example, Twitter. How many of you remember this well of overcapacity? Maybe Twitter was not a big thing in Russia? Probably not. Okay, I can see that nobody's raising, only the Westerners are raising their hands. So when Twitter started, it took a couple of months for it to pick up. It didn't pick up in the very beginning, but then it started really picking up. But they were running out of capacity all the time. And the problem was that they were using Ruby and Ruby on Rails. There is nothing wrong with Ruby and Ruby on Rails. The problem is that it doesn't scale. Hey, I'm a Ruby guy. I started doing .NET in 2009, and then in 2010 I switched to Ruby, and I did it for 7 years. In my heart, I'm a Ruby guy. I was a Ruby fanboy, not anymore. I mean, I've been to rehab, and now I'm not annoying anymore. However, I still love Ruby, all the way in my heart. But I understand that Ruby doesn't scale, and that it leaks memory. It sucks. But the beauty of Ruby, Ruby on Rails, and the whole ecosystem around it is that it helps you to bootstrap ideas real fast. And why am I saying this? Because when you have an idea and you want to test it, you don't want to prepare for scalability and waiting for the million users. No. Start small. Start with a really tiny little project, the scope being really small, and when you test that the idea actually works, like Twitter did, then you can start injecting money into your project. So that's what they did. They're like, okay, the reason why we're running out of capacity is because we're having a massive growth. So now we can get money because now they have the interest of investors. If I come to you with no product and I tell you, can you give me money to build this product? Maybe. But if I come to you with this product that is working and I have 100 million users right now and I tell you, can you please give me some money to make the product grow? Would you say yes? Most of you would say yes if you're a good investor. So that's what Twitter did. So then from Ruby on Rails, when they bootstrapped the idea and they tested that it worked, they got some money and they migrated to Scala. And now Twitter scales massively, and now they build Mesos and they have all sort of amazing infrastructure solutions for their infrastructure problems. But they first needed to start small. So we can see that in the waterfall way of working, there was the developer delivering the software to the testers, and the testers make sure that the applications were working, that the features were compliant with the business requirements, and then they deliver to the operational people. The problem was that there was this wall. Okay, hold on, I have a slide for that. There was this wall that is known in the DevOps world as the wall of confusion, where you as a developer, you finish your software, you package it, and then you over to the operations guy, and then and now it's not your problem anymore. Now it's the operations guy problem, right? And then the operations guy is like, hey, I'm trying to run your code in the test servers, and it doesn't work. And the developer, what is the developer going to say? There you go. Thank you very much. It works on my machine. It's your problem now. And the operator starts like, okay, developers really suck, and I hate developers, right? So there was this. It was all miscommunication. Why? Because in the end, the operator on a Sunday night, 3 a.m., sends an email saying, hey guys, I finally got the application to run in the test environment. It was missing a library. The developer forgot to mention that it needed the goddamn libc header for connecting to MySQL. Thank you, Dick. So it created a lot of tension in between. What was the solution? Okay, Agile. First, to put the developers and the testers together, and then to put everybody together in the same room. And this is where DevOps really started to kick in, or to take off, to say better, because once you put all these guys together, if you're the operator and I'm the developer, and we're in different rooms, I don't see you, right? So it's like the ostrich that puts the head in the hole. So then the lion is not going to eat her, right? It's the same with the developers. Oh, I'm in a different room from the operator. So if we have a tension, well, it's not really there because the wall is right there. This is super toxic for a company. But when you put the two guys together, now I cannot run away from you. If you have a problem with me, you will have to you can tell me because I'm right there with you. There's no escape, right? So this is what we did with DevOps. I don't know if you guys had the opportunity to grow in a very farmy kind of way. So I'm going to tell you a story real quick. I'm running out of time, but I'm going to do it. Okay, so I grew up with in my grandmother's house, and this was in the city, but she comes from the farm world, from the farmland. and she was used to having chicken. So she had chicken in the backyard, right? So I grew up seeing the chicken. And sometimes when she would buy a chicken, when they're very little, you don't know if they're gonna be a rooster or a hen, right? If you're gonna be a rooster or a hen. If there's a rooster in the backyard, and you buy a little chicken, and if the little chicken grows to be a rooster, they're super territorial, and they will start to try to kill each other. So the solution was, or the solution that my grandmother gave to it, was that she tied the two chickens' legs together, and then they were on top of each other, and they couldn't really bite on each other. And after a week of doing that, it was horrible for the animals, but in the end, when she released the cord, they were happy together. So we're doing the same in Devops by destroying the wall of confusion, removing it, and putting it all together. So now there is no email confusion. Oh yeah, I told him in the email that this needs to be done like that. And no, it's like, if you have something that you need to ask me, you ask me directly. The face-to-face communication is way better than the email. We like email because we have the backtrace, and it helps us as an insurance policy, but it's not as effective as face-to-face communication. So this is why DevOps is so powerful in the companies. So this is how the companies were organized in the past for a waterfall way of working. Everybody was, it was like a massive entity. And when we introduced Agile, we started splitting into different teams, right? We have the front-end team, the back-end team, the whatever feature team, the pictures feature team, the message feature team, etc., etc., etc. And now with microservices, we have not necessarily individuals, but even smaller teams. So we're moving there. We're changing the way that we organize companies. However, as I told you before, change is really, really difficult. You need to be prepared for that. You cannot just come to your company and say, we're going to do DevOps today. It's not going to work. So what is DevOps? For those of you who are really curious to see what exactly this thing is. I have a couple of names here. Who would say that is the most DevOps concept, tool, or term in the slides? There is Puppet, AWS, Jenkins. What is more DevOps? Huh? All of one? All of them. All of them are DevOps. Actually, none of them are DevOps. Almost, super close, but not really, because DevOps, there is an interesting talk about Ivan. Ivan, can you raise your hand? You're going to talk about that DevOps is not really about the tools. I don't see, there you go. Thanks. So if you guys are interested, you should go to his talk, because he's going to talk specifically about this, that DevOps is not about the tools. It's not at all about the tools. There are 4 different pillars of DevOps which really make DevOps, and the tools come as a means, not as an end. When people say we're going to do DevOps, they say we're going to install Docker, and then we will be DevOps. It's far from reality. DevOps is not just about the tools. DevOps is the culture. DevOps is about communication, what I was saying, to put people together in the same room so that they can communicate effectively and in consequence deliver value faster and more secure. Collaboration, right? Because if we're sitting together and me as an operator, I don't really understand how your application works, you can explain me face-to-face how it works, and then it's going to be a smoother process for me as an operator to deliver your software. Or even so, you can help me to automate that, right? So then we come to automation, which is all the processes that are being done manually need to be automated. If you guys remember the testers in the past, they would click, 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 click. And then JUnit came, Capybara, Selenium, where we took all this business language, we wrote it in a format, and then it became an automation process, right? It became automated. Now the testers, I'm afraid, and I'm sorry to say this, but the tester role in the companies is shrinking and shrinking and shrinking because it's being automated. It doesn't mean that the testers are going to be fired. Everybody is afraid of losing their jobs. It's not about you being fired. It's about you quitting that job and doing something else that is more productive and that it brings more value to the company, right? So in the same way that we are setting up computers manually, installing MySQL manually on our servers, this needs to be automated. It doesn't mean that as an operator you're going to run out of a job. It means that once the problem is solved, you will need to solve another problem. Think about it. People are afraid that, oh my God, if we introduce DevOps, if we automate setting up servers, I'm going to lose my job. If we take out the manual testing, I'm going to lose my job. Everybody's afraid of losing their jobs. Dude, do you think that you're so undervalued that it's only about the very specific job that you're doing? Do you think that your job is your position, or is it the skills that you have in your head? Is it your ability to solve problems? Do you think that maybe you could not be used as a manager, as a coordinator, as a team leader, or maybe as a software developer? Anything else can be done in a company. It doesn't mean that when you fix one problem, it doesn't mean that all your problems disappears. It just means that you can now focus on different problems. The companies will always have problems, right? And finally, you will have monitoring that is going to help you to keep an eye on how your system is behaving. So guys, I'm really sorry, I'm running out of time, so I'm just going to do express minute here saying that the reason why we're doing Devops is we want to help people to, we want to empower people to deliver software and to deliver value faster for their companies. When you come to your company, think about it. How can we bring value faster to our companies? Are we really ready? Do we have the culture? Do we have the mindset? Do we have the people? Do we have the time? Do we have the resources? Ask yourself about that and think about how you're going to make that happen. Think about the strategy that how you're going to implement it. Do you want to play battleship to implement DevOps in your application? Is that your mentality, or are you going to think it as if you were playing chess? You need to be really smart about it. Companies try to implement DevOps without having a strategy, and they fail. This is where we make money, unfortunately, because they don't have the experience. We do have it. We've seen it. We've implemented, and we've helped them to do that. But if you want to do it without failing, think about the strategy that you're going to use to do that. And I was going to look into the future. Unfortunately, I don't really have time for that. So the summary is that from punch cards to software as a service, we've come a long, long way. Think about it. Think about it for a second and think what this means for your company and the user load that you will have in the future, and are you ready? Ask yourself that. Software delivery is approaching the speed of light. We're delivering software super, super fast. DevOps is not about the tools, it's about the culture, it's about the 4 pillars of DevOps. And finally, strategy is key to success. Guys, I'm really sorry that I didn't have the time to explain everything, but I'm going to be around in the conference, so if you want to ask me anything, please come. I would love you to come by and say hello. Thank you very much for your time. Okay, so the strategy we can talk one-on-one. Please come to me if you think that you're having troubles introducing or convincing your boss to do DevOps in your company. Come to me, and I would love to give you advice one-on-one. To look into the future real quick, think about cloud as a service. Right now we set up the cloud, we set up Google Cloud, Amazon, Linode, DigitalOcean, and all this stuff, but we have to manually do a lot of stuff. There are tools to make it super easy, like Puppet, like Terraform, like SaltStack, all these tools to automate how we define the cloud, right? All the VPNs, all the VPCs, the networking, the security, the servers, the elasticity, the scalability, right? All this stuff, but we have to do it ourselves. What if there was a manifest that we could write where we say, I need this amount of capacity, this amount of networking resources, this amount of storage, and that's it. Give me a cloud. And then this entity will say, okay, well, I have these 3 options for you. Which one do you want? This one is more performant, but it costs you more. This one is cheaper, but it has these drawbacks. But it presents you with options, and then you say, give me the cheapest one because right now I'm running on a budget. So you choose the one, and it creates the whole infrastructure for you. This is where we're going as cloud as a service. This is going to happen. It's not happening right now. We don't know of a company that is working on it just yet, but we understand that this is where the industry is moving towards. That is on one side of things. And the next thing are Uni Kernels. How many of you guys are doing Uni Kernels today? Uni Kernels. Uni Kernel. Кто делает Uni Kernel? Uni Kernel lead. Yeah. Никто. Nobody is doing Uni Kernels. All right, so basically, when you build an application, it is making a bunch of system calls to open files, to open a socket, to communicate with a certain website. It's doing a bunch of underlying kernel calls or system calls, right? And there is a security issue with this, and that is when you run your application, it has all the system calls available for itself. You can see that if somebody breaks into your system and they can make system calls, they can do a lot of damage to your system. If you can build a kernel that has this specific call set for your application, and you can limit the kernel to only do that, and that as soon as your application tries to open a different file or it tries to talk to a different socket that is not meant to, the application gets killed. This is the idea behind Uni Kernels. Some companies have started working on this. It's going to take a couple of years before it really takes off, but this is also another branch of distributed architectures and cloud infrastructure, where we see that the industry is also moving on. And last but not least, that I also don't see here, is artificial intelligence for your infrastructure. So today we set up the scalability policies for our application manually. Okay, if the traffic is more than this, then I want you to scale to 10 servers. And once if for 10 minutes there is no load, decrease the number of servers and all this. But we have to define these policies manually. What if using artificial intelligence, we could scale up and down our infrastructure, and what is more, to set up all the roles for our applications and whatnot. This is something that is not happening today, but I had a talk with Adrian Cockcroft. He was a cloud architecture at Netflix. He was the one that made Netflix awesome on AWS, and now he's working in Amazon, and we were talking about this. He was like, we need this. So I would expect that in the next 3 to 5 years, Amazon comes with something like this. We don't know yet. It might not ever happen, but we see that the industry is already feeling a little itch about this. And with that, I want to wrap it up. Thank you very much, guys. You have been awesome. Thank you for your time. Спасибо.